Hey everybody, this video is going to talk about operations with functions that are using function notation and also something called composition of functions, which you haven't seen before. So operations with functions is going to feel pretty okay. I just want to talk about the notation. So I want you to pause the video. I want you to write these down. They're not as scary as they look. So just a quick rundown. If I want to do f plus g of x, that's really just saying like, hey, I'm going to take whatever the function f of x is and the function g of x, and I'm going to add them together, which is really going to boil down just to combining like terms. Same goes with the difference. If I have f minus g of x, that really just means I'm taking f of x, subtracting g of x away from it, which again is going to be combining like terms. If I'm doing the product of two functions, f times g of x, we're literally just going to take each individual function, multiply them together, which we know how to do. And then if I'm doing the quotient, I'm just dividing two polynomials, which, again, we know how to do. So the function notation here looks a little scary. It's really not that bad. So let's just look at an example here. Okay, let's say f of x equals x plus 2 and g of x equals 4x minus 3. Well, if that's the case, then f plus g of x really is just f of x plus g of x, which is going to be x plus 2, right? That's my f of x, plus g of x, which is 4x minus 3. Now, I don't really need the parentheses here, so we really just have x plus 2 plus 4x minus 3, and we're combining like terms. We get 5x minus 1. So that is what we get. That's the new polynomial we get when we do the sum of f of x and g of x. F times g of x is going to be the same as f of x times g of x, which is going to be x plus 2 times 4x minus 3, and then we're just multiplying. So x times 4x is 4x squared, x times minus 3 is minus 3x, we get a plus 8x here, and then at the end we get a minus 6. My middle terms combine, so we get 4x squared plus 5x minus 6. So that is the product of f of x and g of x. It's just a new polynomial. So operations with polynomials really isn't anything new. We've been doing this. We're just adding some new notation into the mix. The part that's actually new is something that's called composition of functions. And the way I like to think about composition of functions is we're going to be actually taking one function and plugging it into the other. So the function notation here looks a little weird. You'll notice this symbol here. Okay, that is not multiplication. That's an open circle. Anytime you see that notation, you're going to say the word of. This is literally saying f of g of x. Okay, that is what's signifying that we are doing composition of functions. The other way you could see this written is f, and then with parentheses, and then g of x is plugged inside of it. So this is the way I prefer to look at it. It makes more sense to me. This helps me realize, okay, I'm taking the function g of x, and I am substituting it in for the x's in f of x. So let's see what that would actually look like. So again, we've got two functions, f of x and g of x. So my first example here is f of g of x, which means I'm going to plug g of x inside of f of x. So if you look at f of x here, our variable x is going to have the entire expression for g of x actually plugged in right there. So we're taking the function g of x, we're substituting into the variable in f of x, so that this becomes 5x minus 3, right? That's getting plugged into x, and then minus 1, because the minus 1 is coming from my original f of x. So now we're just simplifying. Okay, this would really just be 5x minus 4. Now let's do it the opposite way. Let's do g of f of x. So if I'm doing g of f of x, okay, g of x is going to be like my starting function, and we're going to take f of x and plug it into g of x. So my x minus 1 from f of x is going to get plugged into x here. So I like thinking of my variable as kind of an empty box, and I'm filling it in with that x minus 1. So the way we're going to write that is this is going to turn into 5, okay, and then I'm replacing my x with x minus 1, and then I still have my minus 3 from the g of x function. So now to simplify, okay, it's just basic algebra. We distribute, we combine our like terms, and we get our new function. Now notice f of g of x gives us a different result as g of f of x. So they're not the same thing by any means. Okay? You're going to get different things based on the order of the composition you're doing. So just be careful. Okay? F of g of x, which was this first one, that's what I'm actually saying. F of g of x means I'm plugging g of x inside of f of x. G of f of x means I'm plugging f of x, that function, into the function g of x. So you just have to be careful with that order. All right, I hope the video was helpful. Let me know if you have any questions. The composition of functions definitely can get tricky, especially depending on the function that we're working with. So hopefully it makes sense. We'll be working a lot with this in class. So let me know what questions you have, and have a wonderful rest of your day.